All right. So this presentation is going to be talking a little bit more about what LLMs are, what different types of AIs are. I'm not going to go into a ton of super deep, complex depth, but what I'm going for here is more breadth for covering more topics and giving kind of a basic understanding of what some of the terms people use in AI mean and how they're relevant. I'm also going to talk a little bit about how AI works, just because understanding how it works can be helpful in terms of figuring out an effective way to implement, the best way to use systems, and the best way to use outputs from AI. So the idea here is that having more understanding can be helpful. So a lot of people talk about AI as though it's a magic wand, and it, appears to be magic. There's that old saying that any sufficiently advanced technology appears to be magic. And I think that really does apply to AI, that it's a huge leap forward in terms of technology that's in part allowed for by certain breakthroughs in programming and like a way of thinking about how to program that I'm going to get into here. But it's not really magic. People also talk about it being alive. Uh-oh, my video went haywire. Is AI alive? Um, not really. People talk about it as though it could be soon, and that's something that's important to think about is, the ethics of like if it's alive, does it have rights? But for now, it's just a computer program. Um, so I think it's closer to being a tool. It's just another tool in our arsenal. It's just like using a program, which we're all familiar with doing, or an application. It's just a different type of application. Um, and maybe it's okay to put a little bit of a magic spin on it, and that's kind of cute. And you've probably noticed that everyone seems to use purple sparkles as like the standard icon for AI, which is kind of funny because the idea is that it's like casting a magic spell, right? So, maybe it can exist somewhere in the middle between those. But overall, it's just important to keep in mind that, we're just using an application, right? So it's not something to be afraid of. It's something we've all done before. It's not really any different than using Microsoft Word or using the internet, which most of us are comfortable doing already. So it's not something to be afraid of. So my idea that I mentioned earlier is that this presentation should give people like a standard level of literacy about AI. So you're not just like a caveman using this magic tool. You have some understanding of like what's happening and why and how it works. Um, just like in medicine, where you want to understand the whole body because things are related to one another, it's important with AI to look at it holistically as well, to understand how each of the different parts work, at least conceptually. Right, I'm not expecting people to come out of this course and program their own AI, writing it from scratch. Almost no AI programmers are writing from scratch anyway. They're using other people's work from before them, right? People are just adding to systems. But that adding to systems creates complexity where it becomes important to understand how some of these different subsystems work. Um, and, I think that people can recognize the value of having some basic understanding, right? Like you drive a car and it's probably safer if you understand the basics of like how brakes work, how tires work, how to, pump your tires, how to jumpstart your car, check the oil level, things like that. If you understand some of those basics, it can be safer to operate that car. So, we recognize that basic understanding can be helpful, even though just because you can inflate the tires in your car, you may not be able to disassemble the engine and put it back together again or replace a part that's more complex. There's still value in that basic level of understanding. All right, so I want to go back to kind of the introduction of AI. Things that people might call AI have actually been around for at least 20 years. A lot of that goes back to natural language processing. And we've probably all used this before. Like if you ask Siri or Alexa a question and it's in a sentence format, it's still going to be able to give you an answer to your search, right? So you might search for like, what is the best tacos in New York, right? And Google knows how to take that sentence, how to interpret that natural language, right? How to process it and turn it into computer speak. So we've had things that are like AI basics for a while. Similarly, um, output systems also exist where, sorry, I thought I was getting a question there in chat. Output systems also exist to turn computer speak into plain text. So the difference really between Siri and ChatGPT is, for now at least, unless you're using the ChatGPT plugin, Siri is doing that natural language processing, but it can only handle simple requests and only things that, tie into things that it's expecting. Whereas ChatGPT is able to handle things that, go in a different direction more. One thing that's brought up as pretty important with AI is that, you really want your data to be secure, that you want to make sure that, whatever you have is not being used to train models. Um, and it's just really important, I think, um, to use a paid version of one of these software programs just to make sure that your data is going to be secured. Generally, if you're using a free model, your data is probably going to be used to train AI systems. So, like if you put your life story and your diary or your corporate secrets in there, that's potentially going to become part of a model going forward that people might use. So this came out very quickly with AI that this can be a problem, where uh, someone at Samsung, an engineer, put a bunch of corporate secrets in like a giant document into an AI, but using a free version. And then all of a sudden, other companies were able to ask questions about like Samsung's finances and Samsung's corporate secrets and Samsung's coding. Um, so, it's really important to make sure that you're not using these free systems willy-nilly. I think it's okay to use a free AI, but you just want to make sure you're not putting anything confidential in there. Um, Similarly, if you do want to do anything confidential with data, put anything personal in there, it's important to be using some kind of paid system and potentially to review those terms of service to make sure they specify that your data is going to be secure. Another term that comes up that's important in terms of security is transparent or explainable AI. Um, the way AIs were trained and created, which I'll get into in a little more detail later in this presentation, is essentially rather than computer programmers writing all the code themselves, they asked computers to write their own code. So they said, write code to code yourself to be an AI. And that's kind of, I'm oversimplifying, but how AIs created themselves in a way. The issue with this is we don't really understand how AIs fully work for the most part. So it's hard to fully trust a system. For example, there are a lot of racial and gender-based biases in AI, and that's because AIs were trained on existing literature, which had gender and racial bias in them. So for example, you can't really trust that a AI being used for business purpose isn't going to be discriminatory necessarily. So a goal moving forward is to have AIs where we really understand what's in them and how they work, so that we can have better trust in what's going on there. Another way of securing is on premises. the opposite of this being off premises. So like if you're running a bunch of servers in your business in like an office somewhere, um, and you own that office, you own the servers, that would be on premises. I guess you don't have to own the servers, but you own the office. Versus off premises would be more like if you have stuff in the cloud, with Microsoft or Google or some other big company. Um, we have someone in chat here. Let's see. Okay. So the issue here really would be that just kind of the illusion of control versus whether you really have any more security. So a lot of people think that on-premises is more secure, where you really control what's going on. Off-premises, you really don't have as much control about what's going on. Um, but in general, if you get servers with some big company like Microsoft or Google, um, I think that generally you're probably going to get a higher level of security than you could afford anyway, that you can buy from Microsoft or Google, um, military level or government level security where they have guards on premises all the time and laser systems and whatever else to secure that data. But a lot of people in like the healthcare field, for example, um, or military contractors may have specific needs based on contracts or laws and regulations where they might have to have systems on premises specifically. So is cloud less secure? Again, that's really up to opinion. Um, that's people's personal opinion. So I don't want to get into that too much. Generally, like I said, unless there's a specific law, it's going to just be up to a decision maker's opinion. Another thing to keep in mind is if you're going to buy a system like ChatGPT, paying for a ChatGPT subscription and then running plugins with it or running some other AI that's pre-made versus building your own system. Um, Again, some of this is personal choice. Some of it is cost-based. Overall, though, the cost of training a model has gone down from like 10 million to like 100,000 probably now to train a basic model. That you can just do it all in the cloud without having to buy any specific equipment. So, really it's up to an individual to decide like, is there anything out there that's available that's going to be able to suit my needs? Asking, is it potentially cheaper, even if there is something available to build our own system and run it? Another option is to use an open source model, for example, Meta's Llama, and use that and run it on your own systems, which potentially can be cheaper. One caveat here is that it's very hard to get large quantities of GPUs or AI processors that are needed if you want to run your own systems. So it at least can be easier to run systems in the cloud, just in terms of acquiring those GPUs or AI processors in large quantities. So again, I'm not going to go into a ton of detail, but I want to call out Hugging Face in particular, which I think is really just a nice system for using different open AIs. If you want, you can learn more about how to create your own AI and run it, potentially on Hugging Face. So I recommend checking that out if you want a little more info. So I have a question in chat. What caused the cost of a model to go down by a factor of 100? Yeah, there will be a sharing of this recording. Um, you know, I think a lot of it is just it's easier to create an AI now because people know how it works. I think there was a lot of I guess, monopolization of a lot of GPUs in the beginning. So just so much more processing is available. Also, over time, the process of creating a model has become significantly more efficient, just from people trying different things and finding out what works better or worse. Great question. And that's also over the course of several years, probably, 5 years time or 3 years time. A lot of things can change. So computer vision is another place where I think AI is going to be really helpful and important. Um, Computer vision is when a computer is seeing things like it sounds like. This is frequently used where you're using either a screen reader, right, like an AI that can use your computer and see your computer screen. A lot of us have seen that recently with ChatGPT, and other types of AI have been able to do that for a while. It can also be used if you like hold your iPhone up, right, and you take a picture and ask ChatGPT, hey, here's a bunch of street signs. Can I park here? It's Thursday at 11 p.m. or whatever, right? So that allows the computer to read an image. This can also be useful in industrial settings, in particular for industrial robots. And it's also going to be important for creating robots in like a non-industrial setting. It's probably not much more than 5 years away where people are going to have robots in their home. Maybe they won't own them. They'll still like hire a cleaning service, but the cleaning service might deliver a robot to do cleaning. Manpreet was mentioning in chat that build versus buy can be a really big roadblocker in an organization, that it's hard to get alignment between internal stakeholders before they can agree, that this takes a really long time. And that's a really great point. It can be really hard to get people to agree on that. People have very different opinions. I think one of the most helpful things, if you want to get stakeholders to align, is to first get everyone agree like what it's going to cost um, to create a system to build versus buy in the short term and the long term, right? So like how much it's going to cost in 1 month, how much it's going to cost in 3 months, how much it's going to cost in 5 months. Is there a specific framework for it? Ben Preet is asking. I'm not aware of one, but there probably is. Again, I think a lot of it is just about cost, potentially also about person power, right? How many individuals you have on staff that you're going to be able to put on this task, how many programmers you have. You might want to outsource, like he's mentioning. And that's true, right? So if you want to outsource, you have to think about the cost of that. If you're in-housing it, you should still think about the cost of that, right? That there's still soft costs, even if you already have those employees, you're probably taking them off of some other task. So, it can be complex to figure out that cost. I think that's the first thing that you really want to align on, though. So at least everyone can agree on what it costs to build versus buy. So I mentioned before that there have been systems for a while that do screen reading. In the past, this was exclusively referred to as RPA, or robotic process automation. And this was one of those precursor forms of AI. This term's kind of going away, and people are just generically saying you're going to chat GPT that, or you're going to use Claude to control your computer. But that idea of controlling a computer is at least a derivative of initial technologies in RPA, or robotic process automation. So again, the idea here is that a computer program, or over the internet, a service like ChatGPT is able to see what's going on your computer, to see your screen or read your screen, hence the term screen reader or screen reading. It's using computer vision analysis in order to interpret that. And then it might do things like click on buttons or go to menus. In the past, this has probably been used the most for um, corporate use of legacy systems, right? So if you use a modern computer system, typically they're going to be API calls that you can use to get data in and out and make queries. If you're using some kind of antique system, the only way to interface with it may be to just type things in on a keyboard. right? So rather than have people sitting around typing in on keyboards all the time, it's potentially better to do robotic process automation and have a computer essentially clicking on things for you. This has grown obviously to do more complex things, but robotic process automation initially began as a technology to allow automations within legacy programs that didn't support automation initially. Another term that comes up is deep learning versus machine learning. Um, People probably use them a little bit interchangeably. Deep learning is just more at kind of a corporate level, right? So ChatGPT might be trained using deep learning versus machine learning is kind of smaller amounts of training. But initial models are created, kind of in a factory looking server room, like the one in this image, where you need to have a ton of these processors. I would say if this was an AI server room, it would probably have more cooling because these processors get really hot. Um, but again, this is mostly a difference in scale. Um, One other term that comes up for training AI systems that I think is important is cleaning and labeling data. So data typically will come in an unclean fashion, meaning not that it's dirty, but it hasn't been organized yet. So it's really important to get that data organized, to get it labeled, to get it structured, to put it into tables or something similar like that effectively. Um, So in order to digest that data, it's really important to have it structured in an effective way. In order to train an AI, another important thing that's done is called reinforcement learning or human feedback, can also be abbreviated RLHF. The idea here is that an AI gives you an output and then you grade it. You tell it what you think of that output, what the quality of it is. Um, this allows the system to learn and to figure out like if it's doing a good job, right? So just like a child or a pet, where you're training a child or a pet, or training a grown-up, right? You want to grade their feedback so that they know if they're doing a good job or not. So this is an important part of AIs, right? Where just like on the previous slide where I talked about cleaning, you need to have a lot of humans doing this structuring of data typically. And you're going to need a good amount of humans also to grade the outputs of AI. So there are a lot of things in the production of AIs that actually require large numbers of human employees, which is interesting because everyone worries about AIs getting rid of jobs, which is obviously a legitimate concern because AI is definitely going to get rid of some jobs. But it's also good to keep in mind that creating AIs and also creating the content that's used to train AIs, right? Literature, photographs, paintings, sculptures. Creating all of that content is work that still needs to be done by humans. So there are, jobs eliminated by AI. There are also jobs created by AI. Um, I don't know what the balance is yet. I assume that it will get rid of more jobs than it'll create, but I might be wrong. I might be surprised. The question in chat. Um, so yeah, Robert was asking in chat if we have large numbers of humans interacting in this process, there's massive amounts of bias, right? So definitely there's bias, like I mentioned, in training, because AIs are trained using existing web pages and literature and Twitter and Reddit and things like that, which we all know are cesspools. No, just kidding. But in all seriousness, both the data that AIs are trained on and this human feedback system, both are subject to tremendous amounts of bias. So I guess really the idea is to just try to be better, right? We just want to try to be better and try to, not create sexist, racist AIs. But that's largely dependent on us, or at least to humans. That there is potential for tremendous amounts of bias in the creation of AIs and the training of AI. Um, there is sovereign AI. Yeah. So there is a tendency for data to cluster, and a computer can, to some extent, cluster or group data on its own, basically meaning an AI that's cleaning its own data. This is unsupervised. Um, Obviously, this is subject to the same biases as every other step in the process because the AI that's doing the clustering was trained by humans on human data. So um, I would say, if anything, computer-based clustering is probably more biased than human feedback, just because people are going to, at this point in this day and age, probably try to be less biased than some historic literature that was used to train AIs, which may be more biased. Obviously, it's much cheaper to have AIs training AIs than humans training AIs, but there's a huge loss of quality. One other part of how AI works and how transformers work is parallel processing. Those are twins, I guess. So the idea is that AI splits tasks up into multiple things. That can also be described as tokens, right? So something's tokenized or chopped up into little bits, and then each part of that sentence or request or image are fed into the AI. That's done in parallel, meaning at the same time. And this is why we need GPUs or AI processors specifically um, to do all of this processing. That Basically, GPUs do a lot of parallel processing. They have a ton of tiny little CPUs inside them. AI processors similarly do a ton of parallel processing where they have a lot of tiny processors instead of one big one. And this is important just to have a basic understanding of like why GPUs are important, and how AI is able to do something so quickly, right? Like you make a request like spit out a 20-page document and it just does it like immediately about whatever you want. And that's because it's taking that task, it's splitting it up into bits, and then each processor in that GPU is doing a tiny piece of the task, and then they put it all back together at the end. So like I mentioned, Transformers is part of this. Transformers is basically just a system of chopping tasks up into bits for parallel processing. I don't think it's important to know a ton more than that Transformers are one of the breakthroughs that allowed for GPTs to initially be created, right? So like GPT 1.0, GPT 2.0, coming before ChatGPT 3, which is when we all kind of first interacted with this technology, are all based on transformers. So if people are talking about transformers, they're probably talking about a text-based AI. I think parameters is one of the more important things to understand. So parameters are like bits and pieces of the AI. You'll frequently see AIs described in terms of how many billion or trillion parameters they have. Basically, this is kind of like how many lines of code the AI has. It's not exactly like that. I'm generalizing or making up an example to make it more understandable. But essentially, like I mentioned earlier, AI is kind of trained or taught themselves. And when they did that, they wrote lines of code for how that new AI they're creating would function. And those are frequently known as parameters. So the more parameters an AI has, the more lines of code it has. Typically, the bigger it is, the better it is. Although there's improvements in AI. Smaller models are typically going to be less high quality in terms of outputs than a larger model. So people talk about trying to get AIs that could run on your phone, and you can run an AI on your phone, right? Run it locally where it's totally secure and not connected to the internet. It's just not going to be a very good AI, or it's going to be very slow. So that's the current bottleneck. Again, with slight improvements and training a model, you can make it a little more effective without making it larger. But generally, the bigger, the better for parameters. So some smaller models might be like 7 billion or 70 billion parameters, and some larger models might be like 400 billion to a trillion parameters. One of the ways that AIs try to get around this is called a mixture of experts model. So the idea is that you ask a request, an initial AI looks at that, a pretty small one, decides what kind of request is it. Like, are they asking a question about math? Are they asking a question about biology? Are they asking a question about 17th century literature? And then it ships the problem off to an AI that's specifically trained in that subject area. So this allows AIs to kind of have the performance of a much larger model without being too large. So this is definitely, according to most experts, how ChatGPT works. This is how Mixtral works, if people have heard of that. That's from Mistral Labs in France. Um, it's probably how Claude works as well, and it's probably how Google Gemini works as well. But people mostly have speculated about it for ChatGPT. And as far as I'm aware, no companies are currently saying like we definitely use mixture of experts. Um, yeah. So Robert's asking in chat, how is Perplexity different? So good question. So I use Perplexity as well. That's probably one of my favorite I'll call it an AIs to use. So what Perplexity does is it puts what's called an interpolation or interpretation layer between you and ChatGPT. So it will then say things like, please add in Markdown citations and references, because that's what Perplexity is known for. Um, Checking chat. Yeah, so Perplexity is known for doing citations, which I think is really helpful. Again, all it's really doing is it's asking ChatGPT or Claude for you to run a request, but it adds to everything you say, like please search the web, please find 5 citations or more, please add those citations in Markdown, and then it puts the citations in and pretties it up for you. But it's not necessarily doing anything you couldn't do yourself. I suppose that's kind of their secret sauce, right? They think that they have, like a really advanced way of instructing ChatGPT. But things like Perplexity or other similar models like that, U.com is another one. Abacus Chat LLM is another one that I know of. These are all using the basic models and then just adding some secret sauce to it. So RAG is another important advancement in AI. This is retrieval augmented generation. So in retrieval augmented generation, like it sounds, you're augmenting your generation with a retrieval. So Perplexity would be an example of that, right? Asking for citations to some extent. Typically, when we talk about RAG, we're more talking about an AI that's specifically attached to a document. So this would be like if you use a software like Ask My PDF, or if you upload a PDF to Perplexity or ChatGPT or Claude or whichever service you prefer, Google, whatever, and then ask questions about that document. This is helpful for reducing hallucinations. So hallucinations are definitely a problem in AI. This is where AI, just like that dog in the picture, AI is like puppy. It really wants to please you, but sometimes it makes stuff up. And when it's tripping over itself because it doesn't really know how to answer a question accurately, so it hallucinates. It makes things up that are not true. So by tying an AI's output to a specific document using RAG, we can help rein in those issues. So much like Perplexity, where it's asking for citations, retrieval augmented generation is going to look at a document and make sure that it can find sources for claims made in the output. So if you feed a document about dog food into the AI and then ask some questions, um, that document is going to be referred to as a reference and for fact checking, typically in a separate step, right? First we generate, then we fact check in order to ensure greater accuracy and fewer hallucinations. But hallucination is still possible, right? There can still always be hiccups or mistakes. I brought up before that parallel processing is important in terms of tokenizations. The idea is that a request gets a given number of tokens, whether it's text generation, image generation. This is both tokens for input, so how long a request you can make, more or less. It's not in words or characters, though. The computer chops your request up into tokens and runs them in parallel processing. So you get a certain number of tokens for input, you get a certain number of tokens for output. This is why when you make a request of an AI, um, it might say, oh, you asked for 10,000 words. I'm only able to give you 3,500 characters. That's a common output window control. Or there's also token limits for input for reading documents. So again, the main idea here is that tokens relate to parallel processing, that you're going to get a certain number of tokens for your input and a certain number of tokens for your output. And those limit what you're going to be able to create with the AI in one request. So, if you want to get an AI to write a book, you could do it, but you'd have to do it like 10 paragraphs at a time. So it'd be really annoying to do. And you'd have to use RAG to keep feeding the prior paragraphs in and say, like, continue this story or novel or whatever. But you wouldn't get as consistent an output if you were able to do it in one step because you're chopping it up. On what basis are tokens made? It's not really by phonetics, it's kind of by like just kind of how AIs work. They tend to be 2 or 3 letters long, but you could feed like the same words into an AI and end up with different token breakdowns. I can't really explain, unfortunately, much more than that because I don't really understand it fully myself. But it's basically what you can feed into one content window or going into one AI. So I assume that if you had a more complex AI than ChatGPT, the tokens might be 1 character each, or half a character each. Versus if you had some kind of much simpler AI, you might be able to feed more letters into a single token context window. Good question. No, I don't want to spin. I want to go to the next slide. Okay, so I'll start wrapping up. We're getting close to time here. One important concept to consider that people ask a lot of questions about is law regarding AI. So, like, will I get sued is probably what it comes down to the most. At least in America, I obviously can't speak to globally, but probably similar in most other countries. Suing someone comes down to money, right? You want to get money from them. And in general, people want to sue people who have money. This includes corporations. And people don't really want to sue people who don't have money, which typically is small individuals. Um, in America, you typically also have to demonstrate damages, that someone lost something in money, they had a monetary loss, in order to really get them. So checking chat. I think as individuals, we don't have to be super concerned about getting sued with AI. Um, but I think that, an important concept to keep in mind is that, ethics, which again comes down to money typically with AI, is that a lot of, writers and a lot of painters and sculptors and poets and musicians, all of their creative works was just vacuumed up to create AIs, and then ChatGPT is making billions of dollars, and nobody paid those artists anything. So I think this is something that's going to have to be addressed in the future. I think right now everyone's so afraid of regulation that no country wants to be the first to regulate AIs heavily because that's a money loser, and it's an unpopular kind of decision to make. Um, but I think in the future, in the next generation, Gen 2 or Gen 3 of AIs coming out in 5 or 10 years, ethics will be more of a consideration, and the people whose data was used to train AIs should be getting some kind of compensation. And the biggest reason is that we need people to continue to train AIs, and we basically used every book ever written in the entire internet to train AI, so there's no more stuff left to train them with. So we need people to go out and write new books in order to train more AIs. And no one's going to want to write more books if they're not getting paid to do it. So I think that's going to lead to a system where we want to incentivize creation by humans and creating human jobs. And it's possible in 5 or 10 years, the only human jobs will be writing books and painting paintings to feed into AI machines to create more AIs. But at least, there's still a need for that human creation in order to further AI.